Warning: 8-hydroxyquinoline is slightly toxic and its vapors are irritating. Concentrated ammonia is irritating and corrosive. Wear gloves when handling them. Hi guys, here is MIH. It has been a really long time since I last uploaded because my lab is getting updated and I'm getting some new equipment. However, this 4-month-long ban and chemistry experiment also provided me an awesome chance to study the theories and come up with more interesting experimental thoughts. So here I am, much more knowledgeable, cautious, and fun than before. Anyways, let's introduce our compound of the day. 8-hydroxyquinoline, also known as oxine, is a versatile organic chelating agent and can combine with various metal cations to form fluorescent complexes. Today I'll be making the aluminum complex, tris 8-hydroxyquinolinato aluminum, which has a bright green fluorescence under UV light. For this preparation, we will need 8-hydroxyquinoline, some ammonia solution, and a type of soluble aluminum salt. I used aluminum sulfate just because I had it on hand, but any other aluminum salt such as aluminum chloride would also work. Note that the ammonia cannot be replaced by other bases such as sodium hydroxide. First, 8.1 grams of aluminum sulfate octadecahydrate was weighed out, followed by 5 grams of 8-hydroxyquinoline, which has a slight yellow tint due to oxidation. The mixture was first thoroughly mixed with a spatula and then grinded until a fine powder texture is achieved. I'm a bit lazy, so I didn't use my mortar and pestle, but that will be sure a lot better. After the mixing, the mixture visibly turned yellow. I then added a little bit of water and stirred the mixture to make a slurry. Now, if I place this slurry next to a UV lamp, it is not fluorescent at all. The magic only happens when I dropwise add 2.6 milliliters of 25% ammonia solution into the mixture. Or is the magic actually happening? With stirring, the mixture instantly turns green, but it isn't emitting the strong fluorescence I was expecting. Oh, kind of disappointing. Anyways, I let the mixture stand for a few hours and proceeded to filter it. Again, I'm really lazy today, so I used a crude gravity filtration setup instead of my vacuum filtering system, but it also works quite well. Upon exposing the filtrate to the UV lamp, you can see that it is not fluorescent, but if I hit it on the product, the fluorescence finally starts to show. The problem here is that the product is too compact and squeezed together and doesn't display fluorescence very well. It was also a bit wet, so I scooped it out on watch glasses to allow it dry. Here is one of the watch glasses carrying the product, and you can see that its fluorescence was very weak on the top, but if I flip the watch glass over, the product at the bottom fluoresces strongly. Also, when the product dries out in air, the top layers are still strongly fluorescent. My explanation to this is that our product can react with air in the presence of water to form a non-fluorescent compound. Therefore, after letting the product dry in air, scrape off the top layer that touches the air and keep the stuff at the bottom. Anyways, I proceeded to dry a small sample of my product because the large batch would take a day or so to completely dry out. As the product heats up, it first releases a lot of water vapor. Upon further heating, it turned brown and gives off an irritating smell, probably due to the product's decomposition. I quickly removed it from the heat and transferred it into a glass bottle. Now for the ultimate test of fluorescence. And it was indeed emitting a strong green light. Big success. Because Halloween is coming soon, I decided to use the remaining product as a fluorescent paint to draw something. And here is my crappy artwork, a smiley face. No doubt it is still strongly fluorescent. Beside this first success, I'm also making some other types of fluorescent complexes, which I'll post as soon as I finished. See you soon!